Assalamualaikum warahmatullahi wabarakatuh, and hi. So here is the final video for alkanes. So halogenation of alkane is one of the chemical properties of alkene. So alkane will react with halogens such as chlorine and bromine to produce haloalkene. Okay. So in order for the reaction to proceed, okay, the reaction require light or heat. Okay, so the type of reaction is free radical substitution reaction. So this is the example how the reaction occurs. So for example, if we have methane and we will react with chlorine molecule in the presence of UV, so one of the hydrogen atom will be substituted by chlorine atom. So this is the example of the product. And if we have ethane, it goes the same. One of the hydrogen atom will be replaced or will be substituted by bromine. So for example number 1 and number 2, one haloalkane product is produced. It is because of our alkane contain identical hydrogen atoms. Okay, for example, if we have ethane, okay, all of this hydrogen in ethane is a primary hydrogen. So that's why the product is only one. Okay, because it contains identical hydrogen atom. However, okay, for halogenation of propane here, okay, we react with bromine in the presence of UV and CH2Cl2, we will produce minor product and also major product. Okay, why we produce two products? Because because of the existence of non-identical hydrogen atom. Okay, so we can see that 2-bromopropane is the major product due to the stability of free radical. Okay, so here we have the expanded structure of propane. Okay, so for the carbon here is a primary carbon, so the hydrogen also primary hydrogen. It's same with the carbon here. However, for carbon number 2, okay, the classification of carbon is secondary carbon. It's the same with the hydrogen, so this is also secondary hydrocarbon. Okay, so if hydrogen here is replaced by bromine atom, so we will produce major product, and if hydrogen here is substituted by bromine, we will produce minor product. Okay, so why we have major and minor product? Okay, we can relate it with the intermediate of the species intermediate. That is our free radical. So the most stable free radical is the tertiary free radical, followed by secondary free radical, primary, and the least stable free radical is a methyl radical. So the more stable our free radical, okay, the more high probability tendency to produce major product because it is stable. So alkyl group, okay, will stabilize the free radicals as we have discussed in chapter 1. So in halogenation, we have mechanism. So the mechanism involves 3 steps. So the first step is chain initiation step, and then we have propagation step, and we also have termination step. Okay, so this is the first step that we call chain initiation step. We start the reaction by breaking chlorine molecule covalent bond. So in order to break our non-polar bond, we need UV as a source of energy. So here we have half-headed arrow, 2 half-headed arrow. Each of this arrow will bring 1 electron each. So we will produce free radical. And then, okay, from this free radical, we will go to the next step. That is chain propagation step. In chain propagation step, we have 2 sub-steps. Okay, so here is the chlorine that we produce from the first step. Okay, so the chlorine radical will abstract a hydrogen to generate alkyl radical. So here is a bonding of carbon and hydrogen. So bonding between carbon and hydrogen will break, and then one of the bonding electron will combine with the unpaired electron from chlorine radical, free radical, and the other bonding electron will go to the carbon and produce alkyl free radical. And then 2 of the electron here will produce HCl. And then the second sub-step, where we have alkyl free radical, okay, will react with chlorine molecule to generate the product and chlorine radical. So here is our chlorine molecule. Okay, the covalent bond here will break and each atom will get one unpaired electron. So the unpaired electron here will combine with the unpaired electron of alkyl free radical and produce the product and also chlorine free radical. And then for our last step, this is chain termination step, where we combine any two free radical to decrease the number of free radical. So in this reaction, we have two free radical, two type of free radical, that is chlorine free radical and also alkyl free radical. Okay, so we have three sub-steps in order to terminate, okay, this free radical. So first, alkyl free radical combine with the other alkyl radical will produce this structure, and then chlorine free radical will combine with the other alkyl free radical to produce this structure, and chlorine free radical will combine with the other chlorine free radical and produce chlorine molecule. So this is the step in free radical substitution reaction. So this is the example, okay, where show the reaction mechanism for major product for the reaction below. Okay, as we know, in propane we have two type of hydrogen. Okay, so for hydrogen that attached to the carbon number 1 and carbon number 3, it is a primary hydrogen, and for hydrogen that attached to the carbon number 2, it is secondary hydrogen. So it react with bromine molecule and produce minor and major product. Okay, so here is the step for the major product. First, okay, we will break the non-polar covalent bond of the bromine molecule and get two bromine free radical. Next, for the chain propagation step, okay, the bromine molecule will extract the hydrogen, the secondary hydrogen from propane, and will produce alkyl free radical and also hydrogen bromide. And then here, our alkyl free radical will continue with the bromine molecule. Okay, so we will produce bromine free radical, and here is our major product. And our last step is the chain termination step, where all of the free radical, okay, we will decrease the number of free radical by combining them. So this one is in chain termination step. Okay, so this is for practice 5. Okay, this is for ethane. So if ethane, we only have identical hydrogen that is primary hydrogen, so we only get one product. And also this one is another practice. Okay, so if you have any problem, please don't hesitate to ask your lecturer. Okay, thank you.